Alright guys, well in this video we're going to continue learning about more Maclaurin series, and today we're going to learn about a trick with substitution. So we're going to be expanding on kind of the four main series that we've looked at so far and using these as kind of a starting off point. So just as you guys know, the series for e to the x of course looks like this. It's all the terms x to the n over n factorial. And everyone is positive and everyone is happy because e to the x is awesome. Cosine, remember, is just the even terms, and those of course alternate off and the powers match the factorial. But of course you probably notice that these are kind of the same terms as the series in e to the x, just only some of them and just they alternate and it's the even terms. Okay, and then of course the sine series is the odd terms of the e to the x series, and again we start with a positive and those alternate. Okay, now you should already know these, of course it should be -1 to the n, but these are kind of our starting off point. And if you don't know these, make sure you memorize them, make sure you know them. They will be extremely important for this entire chapter, and then on the AP test they're going to expect you to know them as well. And the 1 or 1 minus x, of course, that's just our geometric series. Okay, so these are going to be our starting points today. Everything is going to come from here. And by the way that I keep these straight for cosine and sine is I know that the cosine of 0 is 1, it starts with a 1. I know that the sine of 0 is 0, and there's no constant in front, it starts with a 0 technically there. So that's how I can keep straight the cosine and sine series. Okay, so let's take a look at, for example, we're going to write the Maclaurin series, and in all the Maclaurin series that I'm going to write today, we're going to write the first 4 non-zero terms in the general term. And on the AP test, of course, and on my test, I'll always be clear about how many terms and which terms to write, but that's just the standard I'm going to go with today. Okay, we're going to write the first 4 terms in the general term of the series for sine of x squared. Okay. Now, let me show you a bad approach to this. Don't write this down or anything. But one thing you could do is you could say, okay, my function is sine of x squared, so f of 0 is 0. My first derivative is cosine of x squared times 2x. To find my second derivative, right, this is how we take a series. We take derivatives and we plug in. My second derivative, though, this is where things go downhill, right? You have negative sine of x squared times 2x times 2x plus 2 times cosine of x squared. So you can kind of see pretty quickly that we're going to get into product rule, chain rule hell, right? You could take a bunch of derivatives, but it's going to get really ugly. So what we want to do is have a faster method for this. And what we're going to do is we're going to start with the sine of x series. And then as I want to go from sine of x to sine of x squared, I'm just going to kind of do a substitution. So I'm going to substitute in wow, I don't know what just happened there. I'm going to substitute in an x squared for this x. So I'm going to start with a series for sine of x, which looks like this. So it's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th. And again, you really need these memorized just to speed things along here. Okay, and then we have x to the 2n plus 1 over 2n plus 1 factorial. Okay, so what I'm going to do when I get to the series for sine of x squared is I'm just going to do a straight replacement into each of these x terms. So just like I replaced this x with an x squared, I'm going to do the same here. So I'm going to get x minus, and then I'm going to get x squared cubed over 3 factorial, x squared to the 5th over 5 factorial, x squared to the 7 over 7 factorial, and even in the general term, I'm going to do the same thing. So you don't need to like memorize any fancy patterns or be able to come up with that. You just need to like plug into the formula you already have. Just replace that x and x squared, and then we're just going to let the math work out. Okay, now as you guys know, the power to a power multiplies, so these multiply out, so you're going to get x to the 6 over 3 factorial, x to the 10 over 5 factorial. This should have been an x squared. I'm an idiot. Good. Yeah, you replace the x with x squared. I'm sorry. And then x to the 14 over 7 factorial. Here, when you multiply out the powers, you got to distribute, right? So that's going to become x to the 4n plus 2 divided by 2n plus 1 factorial. Okay. And that's my series for sine of x squared. So if you go through the bad method and you take 14 derivatives, you're going to get the same answer. But this became a lot easier problem by just handling the sine of x squared, by starting with the sine of x series. Let's do another one. So let's write the series for cosine of 2x. And this is something you can probably go ahead on your paper and anticipate. right? We're going to start with a series for cosine x. If you want to try this on your own, just pause and whatever. But we'll start with a series for cosine x. So again, cosine x is the even powers, and I know that because I'm a good student. I'm trying to do well in this class and everything. So then my general term is the 2n over 2n factorial. Okay, now when I want to get to cosine of 2x, and this, by the way, we put the plus dot dot dot, general term plus dot dot dot. That's just an indication that it goes forever, and this is our pattern. All right, so we're going to replace this x with a 2x, and I'm going to do that in each of these different cases. So this is going to become 1 minus 2x squared over 2 factorial. You have 2x to the 4 over 4 factorial, 2x all to the 6th power. You're replacing that whole x. So the whole 2x is being raised to the exponent. And the same thing on the general term, right? You have 2x to the 2n divided by that 2n factorial. Okay, so if this were a free response problem in the AP test, you could leave it like this. But a lot of times you want to simplify it out just because it'll make plugging in easier. So if I have like 2x squared, of course we know that's like 2 squared times x squared. So that's like a 4x squared over 2 factorial. And this is like a 2 to the 4th x to the 4 over 4 factorial. You might know that 2 to the 6 is 64, but you can just leave it like that. And then you have negative 1 to the n. And here again, you could just write it as 2 to the 2n times x to the 2n, or you could just leave it in that form. It doesn't really matter. Yeah, that should work. Okay, good. Cool. So that's the series for cosine of 2x. And again, if you just take a couple derivatives, you're going to get to the same spot, but this is perfectly fine as well. All right, so let's look at another example here. This one's going to be a little weirder. So we're going to again write the series for x squared e to the negative x. And this one's going to be weirder because we're actually going to take 2 steps along the way. So what we're going to do in this case is we're going to do the substitution first. So I'm going to start with a series for e to the x, and then I'll replace to make it e to the negative x. And then I'm going to multiply that series to get x squared times e to the negative x. We want to do the substitution first so we don't have to replace that too. Anyway, so we're going to start with e to the x, go to e to the negative x, and then multiply. So again, we're starting with e to the x, and of course we're good students, so we have this all memorized already. It's like 1x, x squared over 2 factorial, x cubed over 3 factorial, and then it's just x to the n over n factorial. Sweet. E to the x is my favorite Maclaurin series. So then when I substitute in, I'm going to have 1 minus x. And then here, if I have negative x squared, of course, the negative gets squared. So that's a positive x squared over 2 factorial. The next one, I'll have negative x cubed. So that's like a negative 1 cubed times x cubed. And negative 1 to any odd power is still negative 1. So that's like a negative x cubed over 3 factorial. And then for my general term, that's a negative x to the n over an n factorial. And it might behoove us to write that as like negative 1 to the n times x to the n over n factorial. Okay, so let's talk about the multiplication now. So when I multiply x squared by a polynomial, right? If I do like x squared times 1 plus x plus 3x cubed or whatever, all you do is you distribute it, right? You distribute the x squared to everything. And that's exactly what I'm going to do here. So I'm going to kind of have to distribute out this x squared to the series. So it's x squared times this series for e to the negative x right here. So it's x squared times 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial. And then my general term, negative 1 to the n, x to the n over n factorial. Okay, so again, just like multiplying out, that x squared gets distributed and multiplied out to each term. So x squared times 1, x squared minus x, x cubed. X squared and x squared is x to the 4 over 2 factorial. X squared times x cubed, we're adding those powers, so that's x to the 5th over 3 factorial. And then for my general term, I have x to the 2 times x to the n, so I'm going to add those. So that's x to the n plus 2 divided by an n factorial. And that's my series right there. Okay, so that's how I'd write that as a series doing the substitution. One more thing I wanted to share with you about is something where you might have to do an addition or a division. So if we add or we divide, so let's look at what that would look like. So if I have cosine, so let's say we want to write the series for cosine of x minus 1 divided by x squared. So the steps we're going to work with are starting point is we're going to work with the series for cosine of x, and also this is like cosine of x and then subtract 1. And then we're going to get to cosine of x minus 1, okay? And then we're going to finally divide everything out and get to cosine of x minus 1 all over x squared. So thinking of order of operations, we do the whole top, and then we do the division at the end. Okay, so we'll start with a series for cosine x. So that's, of course, 1, I still have this memorized from like 5 minutes ago or whatever. So it's going to look like this. My general term is still the same. So negative 1 to the n, x to the 2n, and the factorial matches the exponent, of course. Okay, now what happens when you subtract a 1? Well, just thinking about a polynomial, right? If we have, like, say, x cubed plus 7x minus 4, and then you subtract 1, do you subtract 1 from every term? And the answer is no. You only subtract from the like terms, right? So when you subtract the 1, it only affects the negative 4. So like it doesn't affect the x cubed term. It doesn't affect the x term. You just have to subtract 5. Great. Okay, so in this case, when I'm just subtracting the 1, I only subtract 1 from the like terms. So that's super easy. So when I subtract 1, it just does that. So I'm going to be left with negative x squared over 2 factorial plus x to the 4 over 4 factorial. This should have been a minus. Good thing I'm a chump. So minus x to 6 over 6 factorial. If you did need a fourth term, you could just write the next term of the series, right? The positive x to 8 over 8 factorial. Now again, subtracting 1 doesn't affect the general term. It only affects that one term, the like term with it. The general term is still negative 1 to the n, x to the 2n, divided by 2n factorial. Now, my last thing is I divide. Well, what do I do, right? If I have, like 3x squared plus x minus 4, and I divide by x squared, you're just dividing each term by x squared, right? That's how division works with polynomials, and that's how it's going to work with series as well. So that's what we're going to do. Now, let's choose, purple's good. We'll divide each term by the x squared. So when I get to this, I'm basically saying, let's put this over an x squared. So we're going to divide each term of the series by an x squared. Now, don't be too upset about like the fractions and the fractions or whatever, right? If you have like x to the 6 over 3 and you divide it by an x squared, that's just like x to the 6 over 3 times a 1 over x squared. It's just going to cancel the x to the 6 and that. So you can like put it over 1 and flip it and multiply if you want. So anyway, we'll see. This becomes negative 1 over 2 factorial. Here, when you have like x to the 4 over x squared, you subtract. It's x to the 4 minus 2. So that'll be x squared over 4 factorial. X to the 6 over x squared, we cancel 2 of them. So that's minus x to the 4 over 6 factorial. And then x to the 6 over 8 factorial. And even on the general term, right? When I have x to the 2n and I divide by x squared, I subtract those. It's x to the 2n minus 2. So that's going to be negative 1 to the n, x to the 2n minus 2 divided by 2n factorial. So you don't need to come up with a new general term. Just work with the one you have. Okay, so that's kind of how it works. That's how you can do these problems by just kind of doing substitution and working with the series you have and using that as a starting point. Okay, great stuff here. Thanks for watching. I'll see you guys in class. Make sure you bring me some questions.